Martin Schichtel of KraftBlock, thanks for joining us as the first guest in the relaunched M4 Edge. We're really happy to have you here.
I'm really happy to be with you. Thanks for having me.
Excellent. Martin, the show's formal name is Macro, Micro, Michael, Marco, and Startups at the Edge, a mouthful. So we're focused both on the micro, how new technologies work, and on the macro, the impact on our lives and our economy. And in our new iteration of the show, we focus on startups whose tech is especially relevant now. Your company, KraftBlock, fits perfectly. You've developed a new energy technology at a time when the world faces an energy crisis. Now, before we start, we want to prime the audience with 4 factoids. First, in geographic Europe, excluding Russia, natural gas accounts for about 1/4 of total energy use. I'm talking about the geographic definition of Europe here, and so not just the European Union.
And this data is from the International Energy Agency, IEA. So another factoid is that in that same geography, natural gas accounts for about 40% of the heat output from district heating plants, from industrial heating plants, and combined heat and power plants, CHP.
Third factoid, as most people have heard, Europe has relied very heavily on Russian natural gas for about 40% of the total consumption to the EU before the Ukraine war. But that supply has now been cut to about a half of what it was, and Europe wants to cut its reliance on Russian gas even more.
I see you're nodding along. So far, all this is correct to you, roughly, right? So
Yes, so it is.
And then our fourth factoid for the audience: Europe has very ambitious climate targets, and so phasing down natural gas is an environmental goal, regardless of the geopolitical situation. And the EU goal is to be carbon neutral by 2050. So into this scenario steps KraftBlock. So first, if you could please explain for our audience what KraftBlock is and what it does.
Good question. And at the end, simple to answer if you do not jump on the technology itself. KraftBlock itself, if I put it in a nutshell, it's a multifunctional high temperature energy storage system. So at the end, we are storing energy, but in form of thermal energy, of heat. And this is, of course, the perfect step to start decarbonizing different thermal processes or even district heating or heating for houses.
Super.
So, Martin, why don't you elaborate just for a minute more on this? It's an energy storage system. What makes it special? Why is it better, more efficient than other storage systems?
Yeah, first of all, it's an energy storage system, a thermal energy storage system. So what is quite unique in this way is we can store, and now it's in degree C, 1,300 degrees C or something like 2,500 degree Fahrenheit, which is a quite high temperature. So you can serve a lot of applications, of course. We call it system because charging and discharging is integrated to the storage unit itself. So the customer can get a turnkey application from our side. And now the multifunctional part, which is also quite unique, we can decide which is the best way to charge and discharge the storage. So just an example, there's a concept we call waste heat recycling. So we're going to industries like steel, ceramics industry, glass industry, where already heat is existing, especially in the flue gas lines. We can recycle this heat, so recover it from the flue gas, store it into our application and release it to the customer. Or we can charge, like in one of our largest projects at the moment, by electricity. So converting electricity to heat, store the heat, and then utilize the heat. This is one part of multifunctional. The second part is on the discharging device. So we can decide, do we want to produce electricity? Do we want to use the heat as heat? Do we want to produce cold? And this bunch of applications gives us a lot of degrees of freedom to serve our customers.
That's interesting. So you mentioned a few different applications there. What's the profile of an early adopter company that sort of fits the mold most easily for where your company currently is?
The profile is quite simple. It has to have a very strong goal on decarbonization efforts independently, whether it's in their own production or it's in their supply chain. And they should not be risk averse. So we do have a new technology. We do have a young technology that's not proven for 10 or 20 years in the market. But we have shown it in different use cases and scenario that it works. So they only have to jump behind that barrier and say, okay, everything is state of the art except the core itself, but we know how to deal with these risks. And if they do it, they can use it.
Martin, you've mentioned the flexibility of your system. Now, what is the plan? Is the plan to use only or mainly excess renewable energy coming in from the grid? Or is the plan also potentially to have dedicated power? And an additional question, will it not be the case that the excess energy itself will be variable, and won't the excess energy itself shrink over time as we retire fossil fuels?
Yeah, that's a very complicated question. I think we need a couple of hours to elaborate on all parts of this. But no, how do we see it? How do we see the market? We do see two applications. One, as I called it, waste heat recycling, so using existing waste heat resources. I think this will decrease in future because new technologies are evolving, new technologies are integrated in the industries, and so we have a transition path from waste heat recycling to renewable energies at the end. And the renewable energies, I think, for the world, it's the big goal to go over there, whether it's hydrogen, whether it's heat storage like ours, whether it's electricity storages. And a storage system like ours can definitely serve different parts of the energy system, which means also if you think about long duration electricity storages, thermal storage is a wonderful example because you can store at very low prices also electricity. Of course, you have to generate it at the moment by a steam turbine, not the best one, but there are other turbines types coming on the market with higher efficiency. And then in the long term, you do have definitely advantages against other storage systems. For heat, it's even more simpler. So the transition from existing waste heat sources to renewable usage it's the big pathway. And we can see it, especially also in the talks with our customers, where they are today and where they want to be tomorrow.
So that's interesting. I guess I was under the impression that it was mostly from the grid, as Marco's question implied, but you're saying that the big pathway is actually the waste heat. Don't you then have to sort of tune the waste heat and get it up to proper temperature and pressure for it to be used?
You are quite free in your choice on how to work with such a system. For example, we can have pure waste heat recycling. So, for example, steel industry, a lot of waste heat at high temperatures, which can be perfectly recovered and reutilized even for electricity generation. There are other industries like chemical industry, pulp and paper, food industry, which do have a low waste heat potential, so not necessarily usable for our storage. But we could use this waste heat as a base load and then just give a boost of temperature and capacity using renewables, but using the base load of the existing waste heat. So we can, let's say, decarbonize from two sides, using waste heat, but also introducing renewables to the same system. So there are a lot of variations that are possible.
Interesting. Okay, thank you. So you mentioned a minute or so ago some of the other options, and you briefly mentioned hydrogen. I know that in Europe, what's being called green hydrogen is quite popular right now. So tell us why KraftBlock is better than green hydrogen, in your opinion.
It's not better. It's another technology. Hydrogen for us is also not a competition. It's also a chance for our heat storage. So if you think about high temperature electrolyzers operating at 500, 600 degrees C, you could utilize our storage, for example, charging it parallel, but then releasing the energy to the electrolyzer itself, so that we can keep it at the same production power all the times, even if there is less electricity in the grid. So there's also a chance for us. If you think about replacing fossil fire systems, for example, steel industry, food industry, pulp and paper industry, so not the highest temperature in its application, but steam 200, 300, 400 degrees C, which is used in most of those industry, then systems like ours is much more efficient because we convert electricity directly to heat, use the heat and discharge 24/7 to the customer application. And in such a system, from transformer till steam to the customer, you do have losses like 5 to 6%. And you still have much more losses producing your hydrogen before you then start burning it in order to produce the heat, though you have much more losses. So hydrogen is a wonderful tool, especially for basic industries as a long-term energy storage. Means to store the hydrogen for 1 year, for 2 years, for 5 years as backup for the energy system. That's perfect. We never would reach this, but systems like ours are more efficient in a couple of other applications.
Understood. Got it.
Martin, given the flexibility of your technology and given also the magnitude of the energy challenge that we face, the hope has to be that a system like yours can scale rapidly and really contribute to addressing the problem. And I imagine that your vision is also for your technology to scale rapidly. So what needs to happen for your technology to scale up to, say, the goals you're setting for the company for the next 10 years? What needs to happen on the policy front and what needs to happen on the commercial front?
On the policy front, to be very honest, there doesn't need to happen that much, especially for heat application. There are only a few policies to take care about. Electricity is completely different. So if you talk about the electricity market, it's a mess at the end. Each country does have another policy, and sometimes you have double taxation, storing the energy, releasing the energy, getting to no business case at the end. Sometimes it's a little bit better, but for heat, it's not that complicated. So policy could or should support by promoting systems like ours or systems from our competition. At the end, each storage, each energy system that is improved by different means accounts for the future. So I'm not saying KraftBlock will do everything in the world. We will be a big part, I hope. But we need all the technologies in the market to get the system change done. On the sales side, we can see, especially in Europe, a lot of things moving. So when I talked to customers two years ago, for example, the first question was, okay, what is the largest system you built so far? It's 4 MWh. So you never built 20 MWh? No, not yet. Then the risk is a bit too high. Let's wait till you build your first system. With the energy crisis we are facing at the moment, this totally reversed. So usually we are saying, let's build a first pilot like 50 MWh, and the customer say, no time to wait. We have to change our system. We have to get rid of this nasty gas and go to renewable energies. So it completely changed. It's getting a little bit more easier at the sales front. At the end, we have to compare, of course, to different technologies on how to produce heat, whether it's biogas, whether it's hydrogen, whether it's alternative storage solutions, whether it's usage directly electricity, including a battery storage to generate the heat or steam, of course. But that's daily business. That's what we can.
Wonderful. That's all we have for you, unless there's something else that you think our listeners would like to know about you or about KraftBlock.
I don't know what they are curious about. I mean,
we have a curious audience.
I should say, and probably that's not very well known, the heat market is incredibly interesting, and there are only a few players at the moment. So usually you don't think about heat. Mostly in the winter times when your heating at home is too low, you switch it up, you turn it on to be comfortable, warm somehow. But that's all when you think about heat. On electricity, you think every day you have to charge your mobile, you have to charge your notebook, you have to switch and turn light on and off. So you're always confronted with electricity. But roughly 50% of the energy demand worldwide is heat and not electricity and not fuels. So there's a huge market. And if we can decarbonize heat, and you mentioned a couple of figures for Europe, approximately 70% of the heat, especially higher than 400 degrees C, still is generated by fossil fuels like gas, coal, and oil nowadays. And if we decarbonize this, we make a huge step in our race against climate change. And that has to come into everybody's awareness and to everybody conscious to get things running.
Fantastic. Martin, thank you so much for joining us and helping us relaunch our show. So it's great to meet you and great to hear about your company.
Thanks a lot, and thanks for having the chance to talk with you about this. Great.